Greetings to Dr. Noraiham. For this project-based learning assessment, our group is going to present the underground trash collection system and the various processes involved in developing it. In Chapter 1, we start with the problem statement of this PBL, which describes the problems faced by the community of Pangsapuri Bukit Berang Permai due to improper trash management, which are causing bad odors to arise and discomfort the residents, inappropriate disposal of waste such as broken wooden furniture and vehicle lubricant bottles, inadequate and no suitable equipment for proper rubbish collection, and finally, pest and rodent infestation due to the overflowing rubbish. For the objectives of this PBL is to assess the effectiveness of the current state of trash collection system around Pangsapuri Bukit Berang Permai through observation, interview/survey. To design a futuristic design to improve the trash collection system using SolidWorks software, and to propose the design, green materials, and related fabrication process of the futuristic trash collection system through report writing and YouTube presentation. The methodology flowchart briefly explains the processes that our group used to complete this PBL. Firstly, we selected a community and our group has selected Pangsapuri Bukit Berang Permai. Then conducted an observation around the chosen community. Later, a face-to-face interview was conducted with the residents. After that, a group discussion was held to brainstorm the possible solutions to solve the problem. We moved on to designing futuristic trash collection system using SolidWorks software. Material screening to choose the suitable materials and green materials to be implemented. Fabrication process screening to select the most suitable manufacturing process. Optimum layout planning for the futuristic trash collection system. And we ended with report writing and presentation video completion. The slide here shows evidence of community involvement in our PBL. The pictures show the face-to-face interview session conducted with one of the residents as he is complaining about the state of the rubbish bins. And this slide shows the questions asked during the interview session, and a total of 9 questions were asked to each resident. And for the next evidence of community involvement, here we see the evidence of the interview feedback. You can see a screenshot of the feedback questionnaire sent through the WhatsApp by one of the residents. Using the feedback gained, we then made our next move to begin a project proposal. Now I'll pass this to my teammate.
Greetings to Dr. Noraiham. I would like to discuss the chapter 2, which is materials, structures and properties. As an intro to this chapter, this PBL study focuses on identifying and appropriate green materials for constructing the roll-off container and rubbish chute. These are the 2 parts that our group choose from the futuristic trash collection system to perform the material selection. At the end of this chapter 2, we will select the top 2 green materials from the ranking strategy as the material to fabricate the roll-off container and the rubbish chute. The chosen material to conduct the material selection are CFRP, which is carbon fiber reinforced polymer, air-based plastic, stainless steel and iron. These are the properties involved during the material selection, which are toxicity, corrosivity, tensile strength, impact strength, hardness, water absorption capacity, cost, lifespan and energy consumption. Strategy 1 to perform this material selection is translation of design requirements. This part covers the design requirements for the roll-off container and the rubbish chute. As we can see here, the function of roll-off container is to provide a huge space to store the rubbish temporarily without harming the environment. Meanwhile, the rubbish chute is to channel the rubbish directly into the roll-off container, and the constraints are high tensile strength, high impact strength, high hardness, non-toxic, resist to corrosion, resist to water absorption, low cost, longer lifespan and less energy consumption. The objective is to identify the suitable green material which is high durable for futuristic trash collection system, includes the roll-off container and rubbish chute. The free variables is choices of material. Strategy 1 also covers the data attributes of the chosen materials, which are CFRP, ABS, stainless steel and iron. As I mentioned just now, the properties involved are tensile strength, impact strength, hardness, toxicity, corrosivity, water absorption capacity, cost, lifespan and energy consumption. The values obtained from the conducted literature review for each of the properties. That's all from my part. I will pass the material selection strategies 2 and 3 to Ganapati. Thank you.
Next, I'm going to present strategy 2 in the material selection process, which is the screening using constraint. This strategy is crucial to identifying and screening the material properties. The list of materials that are subjected to this screening process are stainless steel, iron, ABS, and CFRP. As we can see from the table, the properties such as tensile strength, impact strength, hardness, toxicity, corrosiveness, water absorption capacity, cost, lifespan, and energy consumption vary for different type of materials. Next, we need to search and determine the value for each of the material properties. If we have a range for the material property value, we must calculate an average value for it. As we can see from the table, all the material properties value are specified. After completing strategy 2 in the material selection process, we move on to strategy 3 in the material selection process, which is the ranking using objectives. In this strategy, we give full 10 marks for the material that have excellent value in specific properties. For example, stainless steel has the highest tensile strength for any type of material. As a result, we give stainless steel 10 points and use tensile strength value as a benchmark to compare the tensile strength score for other type of material. After obtaining the value for each material property, we sum the value for stainless steel, iron, and ABS. As we can see from the table, stainless steel has the highest score. Thus, it is assumed to be the best material for manufacturing the roll-off container and use the second-ranked material ABS to manufacture the rubbish chute for our hydraulic trash collection system.
Now I'll be talking about a bill of material for our trash collecting system. The total quantity of parts involved is 16 parts and the total cost of the raw material needed to fabricate our system is approximately 7,942 ringgit. Next, I'll be talking about the phases of underground hydraulic trash collecting system. There are two phases involved in this trash collecting system. The first phase is where the hydraulic scissor lift goes up from the underground to the ground level, and the second phase is the displacement of the roll-off container. This is a simple demonstration of our trash collecting system using the SolidWorks software. First, when the truck comes to collect the trash from the roll-off container, the trash collector must press the lift up button to lift up the roll-off container from the underground to ground level. Once the container has already reached to the ground level, the lower hitch of the truck will be attached to the container's hook. Then, the truck will pull the full roll-off container out from the system and replace it with an empty container. Lastly, the full roll-off container is locked on top of the truck and the empty containers will be placed into the system. This is the layout of how we are going to place the underground hydraulic trash collection system at the Pangsapuri Bukit Permai residence area. There are a total of 3 residence blocks in this area and the trash collecting system will be placed in between of these 3 blocks. Thus, there will be a total of 2 systems for this particular residence area.
Assalamualaikum warahmatullahi wabarakatuh. My name is IZZAH and I will be presenting on the fabrication process for our underground hydraulic trash collection system. We will be focusing on 2 main parts, which are the rubbish chute and the roll-off container. We implemented the design for manufacturing or DFM, where we firstly determine the shape attributes and the material requirements for both parts. Then, we implemented the compatibility matrix of processes and materials, where each materials has their own corresponding manufacturing processes. Then, the outcome of the compatibility matrix are narrowed down with the shape generation capabilities of processes to determine the final fabrication process. As for the rubbish chute, the structural foam molding will be utilized as the fabrication process. Firstly, the ABS pellets is obtained and then the structural foam molding will be used to process the rubbish chute lid as well as the body. Lastly, the rubbish chute lid and body are assembled to form the final product. Next is the roll-off container, where electrical discharge machining or EDM will be utilized to fabricate the part. Firstly, the stainless steel solid sheet is obtained and then the EDM will be used to cut the solid sheet to form the door, walls and base. After that, the walls and the base will be assembled through welding process. Then, the walls with the base will be attached with the door through its hinges. And lastly, the body of the container will be assembled with a door handle, hook and wheel using screws. That is all from me. I will pass the presentation to the next presenter, IZZAH. Thank you.
I'm IZZAH and I will explain about the process selection of each part. First, the roll of container hook. The material is stainless steel and the process is forging process. Second is the wheel. They're made from rubber and the process is extrusion. Third is the lower chassis. The material is stainless steel. The process is cutting, bending, and welding. So the fourth is the upper floor. The material made from rubber and the process is compress molding. The next is the upper chassis. Same is lower chassis, which is stainless steel, and the process is cutting, bending, and welding. Then protective bar, they were made from stainless steel and the process is cutting, bending, and welding. And last is the switch panel box. They're made from stainless steel and the process is cutting, bending, and welding process. So these are the challenges and recommendations that we've gone through during our project. In the conclusion is, this study for the current condition of collecting bin need to be improved. We brainstorm on how to innovate a futuristic bin that includes green material for the users. Research problems that happen and do a survey at the resident to collect their data. So these are our suggestions on the idea of futuristic bin. The trash bin were made into the underground because to reduce the trash being exposed to wildlife, to prevent the place being smelly as the trash keep on piled up, and last but not least, to have more space for the resident to throw away their trash without any problem. That's all from us. Thank you.